Good morning, students. Now discuss the unit 6 gaseous state. Okay, so the so many of the properties of matter, the especially when is gaseous form, can be deduced from hypothesis that their minute part are in rapid motion. So the velocity increasing with temperature, that the prices nature of this motion becomes a subject of rotational curiosity. Okay, this is the gaseous state. After studying this unit, now discuss the state, the laws governing an ideal gases. The demonstrate gas law in various real life situations and derive ideal gas equations and perform calculation using it. Then state the derivations from ideal behavior and then derive van der Waals equations and then define Graham's law of diffusion and define compressibility factors and explain critical phenomena and derive critical constant is terms of van der Waals constant explains Andrews isotherm of carbon dioxide and Thompson effect and liquefied of gaseous. This is the gaseous state. Okay, so the gaseous state of the first one, the introductions of gaseous state. So we can survive of week without food, days without water, but only minute without air. So thus we inhaled a lungful of air every few seconds, keep some of the molecules for our own end. So and some of the molecules that our body no longer needs and exhale the mixer back into the surrounding air. So the air around as in the gaseous state, which is the simplest of the state of matter. Although the chemical behavior of gases that depend on their composition. All the gases have the remarkably the similar physical behavior. Is the gaseous state. Okay. The next, the earth is surrounded by an atmosphere of air whose composition is the volume percentage is roughly 78%. So the nitrogen 21%, the oxygen 1%, other gases. Of the known element only even are gaseous under normal atmospheric conditions. The element hydrogen and nitrogen, oxygen, fluorine and chlorine exist as gaseous diatomic molecules. So another form of the oxygen, namely ozone, is also a gas at room temperature. So the noble gases, the namely helium, neon, argon, krypton, xenon and radon of 80th group are monoatomic gases. So the compounds such as the carbon monoxide, next one the carbon dioxide and nitrogen dioxide and nitric acid also exist in gaseous state under normal atmospheric conditions. So in this unit, you will learn the properties of gases and other related phenomena. So first one discuss the gaseous law. Now discuss the gaseous law. The gaseous laws have played a major role in the development of chemistry. The physical properties of all gases are governed by the gas laws that were formulated based on the studies of the properties like pressure, volume, etc. As the functions of temperature, before studying the gas laws in detail, let us understand an important parameter, namely the pressure. So the pressure is defined as force divided by the area to which the force is applied. The SI unit of pressure is Pascal, which is defined as the 1 Newton per square meter. There are other units that are commonly used under relations with the SI unit is the follow this. the pressure is equal to N or kg meter per square divided by area meter square. So the N per meter square. This is the pressure. The Boyle's law. Discuss Boyle's law. The Boyle's law, the relations, the pressure and volume. Okay, the Boyle's law relations, pressure and volume. So the mercury was added through the open the end of the apparatus. Okay, so the mercury level on both ends are equal as one in the, see this picture. So add more amount of mercury until the volume of the dropped air is the reduced to half of it. Okay, so the original volume, see this. Okay, the next one, the pressure exert on the gas by the addition of excess mercury is given by the difference in mercury levels of the tube. So the initially the pressure exerted by the gases is equal to 1 atmosphere. So as the difference in the height of the mercury levels is 0, so when the volume is reduced to half, the difference in mercury levels is increases to 750 millimeter. So now the pressure exerted by the gas is equal to 2 atmosphere. This one, 2 atmosphere. It led him to calculate that a given temperature, the volume occupied by a fixed mass of a gas is inversely proportional. The volume, the inversely proportional to the pressure. Okay, so the mathematical, so V is equal to K, constant K 1 by P. Okay, see this is the mathematical. The first one, V proportional, V inversely proportional P. So the T and N fixed the temperature and N is the number of moles. So V is equal to the constant pressure. So constant K means the proportionality constant. So V is equal to K 1 by P. So PV is equal to K. So the K means proportionality constant. Constant means temperature and mass. So the next one, discuss the mass of the laws applications. So the Boyle's law is applicable to all gases, the regardless of their chemical identify. So therefore, for a given mass of as the under two different set of the conditions, this one, P1 V1 is equal to P2 V2 is equal to K. The K means proportionality constant, temperature and mass. Okay, see this, the volume, the V proportional to the inversely proportional to pressure. This is the atmosphere value. This is the V dm cube. The D means density, M means mass. Okay, this is the graphical representations of the Boyle's law. So the PV relationship can be understand as follows. This, the pressure is due to force of the gas, the particulars and the walls of container. So if a given amount of gas is compressed to half of its volume, so the density is doubted and number of particles, the heating until area of the container will be doubted. Hence the pressure would increase twofold. Okay, this is the graphical representations of the Boyle's law. Okay, the Boyle's law, the consequence of the Boyle's law. The consequence of the Boyle's law, see this, the pressure density relationship. So the Boyle's law, so the P1 V1 is equal to P2 V2. So the V value substitutions. Okay, V value substitutions. This is the V value substitutions. So V value M divided by T1. V2 value M divided by T2. So the M is the mass and T1 T2 is the density. So the pressure P1 and P2. So the P1 divided by D1 and P2 divided by D2. So in other words, the density of a gas is directly proportional to pressure. This is the Boyle's law. Okay. Thank you.